Hi, I am Dr. Urijit Shah, Associate Professor of BP Poddar Institute of Management and Technology. Today, I will come to the part 2 of my lecture, that is of digital image processing fundamentals using MATLAB. In the last lecture, we had discussed about various fundamental commands, how to read, how to write an image, how to display an image, different data types, the image types, already we have studied. So now, today we will start with the conversion between the data classes. So general syntax that is given as B equal to data class name A. Here data class name is one of the names of the classes. Example, double, unsigned integer 8, unsigned integer 16, etc. An example is given. Suppose that A is an array of class uint 8. A double precision array B is generated by the command B equal to double of A. So MATLAB expects operands in numerical computations to be double precision floating point numbers. If C is an array of class double in which all values are in the range of 0 to 255, then the values of C may contain fractional values. It may be converted to an uint 8 array with the command D equal to uint 8C. So we can see that from one class we can easily convert to another class. If C has any values outside the range of 0 to 255, then by the above conversion in MATLAB, all the values less than 0 will be converted to 0, whereas the values above 255 will be converted to 255. And numbers in between are converted to integers by discarding their fractional parts. The IPT or image processing toolbox provides the following specific functions that perform the scaling necessary to convert between image classes and types. The names are like im2 uint 8, im2 uint 16, matte to gray, im2 double, im2 black and white. Function im2 uint 8 detects the data class of the input and performs all the necessary scaling for the image processing toolbox to recognize the data as valid image data. Similarly, function im2 uint 8 will set to 0 all values in the input that are less than 0, sets to 255 all values that are greater than 1, and multiplies all other values by 255. Rounding the results of the multiplication to the nearest integer completes the conversion. Rounding behavior of im2 uint 8 is different from data class conversion function uint 8. What is function matte to gray? Similarly, as the previous one, using the function matte to gray, an arbitrary array of class double is converted to an array of class double scaled to the range of 0 and 1. What is the basic syntax? Basic syntax is simple. G equal to matte to gray A, min, max. Here, image G has values in the range of 0, that is black, to 1, that is white. Min and max are such that the values less than min is A becomes 0 in G, and values greater than max in A correspond to 1 in G. Similarly, for function im2 double, it converts an input to class double. For inputs of class uint 8, uint 16 or logical function, im2 double converts it to class double with values in the range of 0 and 1. For input of class double, im2 double returns an array equal to the input. Conversion from class uint 8 is done by dividing each values of the input array by 255. Similarly, conversion from class uint 16 is done by dividing each values of the input array by 6, 5, 535 and so on. Function im2 bw converts an image to binary image. General syntax is G equal to im2 bw ft. Here G is a binary image and F is an intensity image. T is defined threshold value. Output binary image G has values of 0 for all pixels in the input image with intensity values less than T and 1 for all other pixels. The value of p has to be within the range 0 and 1 regardless of the class of the input. Output binary image is automatically defined as a logical array by into BW. But if the value of p is not specified, then IPT uses a default value of 0.5 for p. For input of class int8 into BW, divides all pixels by 255 and then applies either the default or a specified threshold. For input of class int16, the division is by 6, 5, 535 and then so on. For input of class double into BW, applies either the default or a specified threshold directly. For input of class logical array, the output is identical to the input. A logical or binary array may be converted to a numerical array by using any of the 4 functions listed below, that is into int8, into int16, mat to gray, into. Concepts on matrix indexing, we know all these things already. So as we have shown over here, let A be a 3 × 3 matrix as it has been already shown. To extract the top 2 rows, what is the command? We know we have to give A of 1 to 2 and 1 to 3. To extract the last element of A, we have to give A. Use of colon is helpful when we want to find the sum of all elements of a matrix. Like we can say S equal to sum of A colon. That means all the elements are taken and the summation is given. If a matrix is input into sum, the output is a row vector containing the sums of each individual column of the input array. By sum A colon, we actually implement sum of sum A. Selecting the array dimensions, let A is an array of size m cross n. So using the command k equal to size of A1 gives the size of A along its first dimension defined in MATLAB as a vertical dimension. So by the above command, the number of rows in A is specified. To get the estimate of the number of columns, that is horizontal direction of A, we have to give the command k equal to size of A, 2. Hi, I am Dr. Orijit Shah, Associate Professor of BP Poddar Institute of Management and Technology. Today, I will come to the part 2 of my lecture, that is of the. Now the IPT supports some image arithmetic functions. They are being listed. That is addition of 2 images, IMAD, subtraction, IM subtract, multiplication, IM multiply, division, IM divide. Then the absolute difference between 2 images, IM abstif, complement of an image, IM complement, which can give you the negative of an image, and the linear combination of 2 or more images, IM lin com. Function max and min, we can see over here the syntax. There are different syntaxes for finding out the max. Max A, max AB, max A dimension, then max with some dots. All the things are written over here, what they are giving. We want to specify some specific functions. Is cell C, is cell string, is char, is empty, is equal, is p, is finite, is infinite, is logical, is later. The descriptions are given. The table is continuing. Is member, is not a number, is numeric, is prime, is real, is first, is structure, is space. All the descriptions are given. Hi, I am Dr. Orijit Shah, Associate Professor of BP Poddar Institute of Management and Technology. Today, I will come to the what is vectorizing loops. It means converting for and while loop to equivalent vectors or matrix operations. Result in significant gains in computation speed. Example, suppose we want to generate a one-dimensional function of the form fx equal to a sine x by 2 pi for x equal to 1, 0, 1, 2 to m minus 1. We may do this using for loop, as for x equal to 1 to m, fx equal to a sine x minus 1 by twice by n. Same code may be made more efficiently by vectorizing it, as first we are vectorizing x equal to 0 to m minus 1, and then we are writing out f is equal to a sine x by twice pi. This example given illustrates one-dimensional index. Two-dimensional indexing is required. MATLAB provides a direct way. The function used is mesh grid. Syntax is CR mesh grid here. Function transforms the domain specified by row vector C and R into arrays C and R that may be used for the evaluation of functions of two variables and 3D surface plots. Rows of output array C are copies of the vector C and columns of the output array R are copies of the vector R. Pre-allocating arrays. To improve code execution time, we may pre-allocate the size of the array in a program. When working with numeric or logical arrays, pre-allocating simply consists of creating arrays of zeros with proper dimensions. Example, suppose we are working with images F and G size 1024 plus 1024 pixels. Pre-allocating can be done by F equal to zeros 1024, G equal to zeros 1024. Pre-allocating also helps to reduce memory fragmentation when working with large arrays. With this, we come to the end of the part 2 of our lecture on digital image processing fundamentals using MATLAB. Thank you for your patience.